We're going to talk about how I helped enable a community at the ISAC with using some open source tooling. So here's a look at the agenda in which we'll go over today. But first, we'll do a little bit of background on what the ISAC is. For those of you that are unaware, we're the Retail and Hospitality Information Sharing and Analysis Center. And we like to place an emphasis on the sharing part of that. And what that means is we're a secure place for consumer-facing organizations to come together to share related cybersecurity information and intelligence and to not only protect their own companies, but to help strengthen the entire sector as a rising tide lifting all boats. Currently, we're just over 250 member organizations with over 3,100 member users in our community. And the chart on the right is just a little breakdown of the different types of sectors that our members are in. We're not just retail and hospitality. We also have consumer packaged goods, restaurants, food retail, travel, loyalty companies. Basically, if you are consumer facing, you'd be eligible to join our ISAC. And besides just the sharing community, we also offer multiple different working groups as listed here, whether it's like security-focused collaboration groups or tool-specific based groups, like our MISP working group or our special interest groups. Some of these groups are run on different cadences. Some are bi-weekly, some meet monthly, and some meet quarterly. But enough about what my organization is. Now I would like to talk a little bit about MISP. So first, we'll start with our MISP architecture overview for our infrastructure. A little bit of background. We wanted to build this out as like an enterprise application. We were replacing a proprietary threat intel platform at the time, and so we really wanted to make sure that the data in there was going to stay in there. If a member tried to log in and access MISP, they would be able to access MISP. And so we ended up going with a high availability serverless infrastructure hosted in AWS. Our images are built up in the Amazon ECS, and they reach into the Amazon Elastic Container Registry to pull down our image, which is just a clone of the MISP Docker repo with just some slight tweaks and modifications for our environment. We have different images spun up across different availability zones, at least 2 instances, one in each availability zone at any given time. As load on the MISP increases, the servers it'll spin up more and scale up to meet demand. And we have separated out the database into Amazon Aurora, and that's the same thing. It also scales up and down as load on that is needed. And all of that is behind our AWS Elastic Load Balancer, and sitting in front of the load balancer is the AWS WAF. And we mainly just use some of the built-in AWS rule sets. We're not doing anything custom there. As far as our authentication, we have tied our authentication into our SSO platform, in which we use, which makes it really nice because we have some automation in the background, so we don't have to worry about user administration at all. All of that's handled by our membership team, so as we have members get credentialed into our sharing platforms, they automatically have access to MISP and can access it through there. And looking at the right-hand side, over here, we use AWS Lambda to run some automation. One being to log into our Microsoft Outlook mailbox to make use of our mail to MISP. We have some members that share Intel. They send an email to our MISP inbox, and the Lambda will log into that, parse it out, and create MISP events, and then push that back through the front door, through the WAF, into our instances. As well as the Lambda also runs our Peyote enrichment and vetting. So as part of like all the intel that comes in, we're using Peyote, the Python Open Threat Intelligence library that I've developed and that we published under our RHISAC GitHub. And that'll check, depending on the indicator type, it'll send to different intel services, do lookups, find the reputations, and then pull all that back into MISP. And then a TLDR on our build, our image build process. clones the repo and pulls in any needed submodules, like our RH-ISAC taxonomy or threat actor galaxy and our fraud galaxy. It'll then get the needed AWS credentials, logs into the Elastic Container Registry, builds our Docker image, also tagging it appropriately, pushes that back to ECR, and then we'll stop an existing MISP task, launches a new one, and then we're also ensuring the stability of our new images. I should mention that we have a pre-production environment and a production environment that are identical to this. So as we build out new images with new updates, we'll test it in pre-prod, and then once we're all good there, we push it over to production. I just wanted to talk a little bit about our community usage over the last year. At the RH-ISAC Cyber Intel Summit last year, the beginning of October 2023 was when we officially launched our community instance. So these are the numbers over the last year. You can see we have 239 organizations that have had at least one person log into it at least one time. So out of 251, that's a pretty high number. We've had 904 users log in to MISP at least one time. We have around 91 API users currently. And then the bottom is just a breakdown of the different MISP events. And I've split it out into core member and the RH-ISAC Intel team. And the only really differentiator between that is like the platform in which our members are sharing the intel on. We have several different platforms that members have access to, one being our Slack workspace. We have what we call the member exchange, and that's just kind of like a forum board. You can post a thread, reply. We have lots of different areas. We try not to restrict and tell members like, hey, this is the one way you need to do things, and stick to it. So we try to be more flexible. And as you can see over the year, it's almost a fair split down the middle in terms of getting members to buy in and start contributing directly to MISP. And that could be whether, either they're logging into the platform and creating an event manually and sharing it there, or they've set up some sort of automation to push events directly to MISP. I mentioned some of the different platforms in which we have. So on this left-hand side here, this is going to be all the sources of where intel in our community can originate from. Regardless of where this is being shared, it then gets pulled into our community MISP instance in the middle. And then our enrichment and vetting process is run on all the intel within there, pushed back into MISP, and then made available for dissemination through these different avenues on the right-hand side. Whether that's logging directly into MISP, someone wants to search for an indicator, hey, has this been seen? They have some sort of automation set up via the API through scripts or integrations. And then we also have some members that run their own MISP instance and get the intel through the MISP synchronization. Over the last year, our Intel team, we've decided to develop our own classification taxonomy. So this kind of breaks down three different things. The Intel source, which platform was the Intel shared on, the member industry, who shared the Intel, what industry were they in, and then finally the threat type. And this is just kind of like a generic threat type classification. This is not the all exhaustive list for threat types on the right-hand side. I just wanted to get a screenshot that would fit, and you wouldn't have to squint to see it. So by having these three different predicates in the taxonomy, now we're able to kind of do more granular breakdowns and reporting around the intel that is being shared. So looking over the last year at where the intel was shared, we can see that the largest chunk has been to MISP directly, which is great. That means that we're getting members that are buying into wanting to use the platform, whether they're automating it, whether they're logging in and sharing it. And then second behind that is going to be the mail to MISP. That's a great way. Before we had, when we started really using the mail to MISP, we had just a traditional email listserv, in which members, every member could send an email. It would get sent to all the 3,100 plus analysts. And then internally we were talking, and maybe that wasn't the most secure way to be sharing intel, and just having unencrypted intel sitting in 3,000 plus inboxes. So we've since decommissioned the listserv, and now we just have a single inbox where if members, if that's their preferred way to share, great. We'll encourage that. We'll keep pulling that in. And third behind that is Slack. And we have a dedicated channel called IOC, specifically for sharing indicators, intel. And so, again, we want to allow members to share whatever works best for them. We don't want to add any complications to their process. We want to encourage sharing, not disencourage it. Looking at the member industries that shared intel over the year, it's overwhelmingly been the retail members. There's nothing really to gain insight-wise from this, except that we hope to continue to push MISP, get members to see the value in it, and hopefully as they continue to share more, we'll get a more diverse set of intel being shared to our community. And then finally, our threat type breakdown. So over the last year, an overwhelming amount of the intel, nearly 50% of it has been credential harvester intel. And almost a quarter, maybe a little bit more than a quarter, that has been the call center phishing or like the callback malware. That's been an extremely hot trend right now. Google Groups phishing, Geek Squad, all that stuff. And then this last chunk here is going to be malware delivery. So this is initial access intel being shared, but maybe it wasn't specifically attributed to a certain malware family. And so we just kind of label it as malware delivery. And then as we get more granular, as members get more granular in what they're sharing, then we can tag it appropriately. Is it an info stealer? Is it a loader? Is it et cetera. So we have created our own galaxies within MISP. Currently, we have our threat actor galaxy. Many of you are probably familiar with the threat actor galaxies out there. There's a few of them already in MISP. But we decided to catalog some of the most prolific or prominent threat actors that are known to target our members' industries, specifically, whether that's, they go after retail or hospitality or travel. But we wanted to focus our efforts there as a starting point and then make that available as a resource for members to use. So whether they want to, hey, what intel do you have on Scattered Spider? Well, they can log in and they can look at our Scattered Spider threat actor profile. But then we can also then use that to tag all of our intel as well and kind of create that historical archive of all the shared intel attributed to this group. But something I'm more excited about is our fraud galaxy that we're working on. And this is going to be the knowledge base of the numerous different fraud types that are affecting the RH-ISAC members, and then can also then be used to help enable them, regardless of their team size or budget, to help combat fraud. And what that is going to look like is this. So we've tried to identify, by working with some of our retail, hospitality, travel, gaming members, what are the fraud types that their teams are dealing with, and basically just listing them all out. There's like the overall, overarching, say, like receipt fraud, but within that, there's multiple different sub-fraud types of receipt fraud. And so I took a little bit of inspiration from the Attack for Fraud galaxy that's already in MISP, and then wanted to make this out into like a matrix view so that we could have and highlight all the different fraud types, sub-fraud types included, that we'll then be able to then use when members share intel on this. We can tag it appropriately. But then also be able to, for those members that maybe are looking to build out a fraud capability, give them a place that they can come and they can, learn from and identify, like in this example, what is digital skimming? I'm not too sure. And, they can read the description and say, oh, okay, that makes sense. And then by utilizing some of the elements in the galaxy, we can highlight certain things like, hey, here's the certain or specific member industries that this fraud type is going to affect. Digital skimming, if you have any sort of online presence where you're taking payments, you're probably susceptible to this, as well as being able to list out potential mitigations for the fraud types. So, scanning for your vulnerabilities regularly, taking inventory of your assets, and so on. And then as we work more with our members, collaborate with them, we're hoping to identify detections, and whether that's, go here, do this, or if it's, just actual like detections like KQL queries, for example. The possibilities are pretty limitless because the elements are fully customizable as they're just key value pairs. We'll move on to our intel sharing and normalization. So when we were sharing on the listserv, or our members were sharing on the listserv, we had a sharing template. It was basically just HTML table that would paste into the email. This is what it looks like, and I've also then converted our sharing templates that we have to the MISP template. So, if they wanted to log directly into MISP, create an event and then populate from a template, they could then choose from our templates. Makes it real easy for them to just paste in, highlights the different indicator types, for example, credential harvester, phishing email, phishing sender, subject, IP source, embedded link, etc. And we also use this for the mail to MISP. So, a member will share some intel with this template. They'll send it to our MISP inbox, and as part of the AWS Lambda automation that we have, it'll log in, read the email, parse out this template, and then it'll populate a MISP event, and it'll keep it contextualized too, which is great. And then moving into mail to MISP, we're currently using a fork of mail to MISP. It's been a while when we kind of forked it out. As I mentioned, we have it, and we added the part to be able to log into the Microsoft Exchange O365. So I don't have to grab an email and then feed it to the library. It'll just set up and run and go and grab it. It helps connect our infrastructure into MISP and replaces our old listserv. We also rely a lot on MISP objects. I'll keep repeating this, but the context is king. The more context we can provide to the analysts when they're looking at intel, the better that they're going to be suited. They can look at something and say, oh, okay, here, for example, if we use comments and tagging, and so if they look at an IP address and email sender IP, they know undoubtedly that's what that was, and instead of just being a list of, say, here's a bunch of senders, here's a bunch of IPs, here's a bunch of URLs, you lose a lot of context that way. So by using the MISP objects, and these are three that we've created and added to the MISP objects repo, but by using these now we can keep that context together and then make the intel more valuable in the end. We've also gone ahead and created our own documentation for using MISP and how we'd like to advise our members to use MISP. So whether that's creating our PDF documents, someone just wants to pull something up quick and read it. We've also gone ahead and made video documentation or tutorials to follow some of these things as well, that kind of step-by-step walk members through how to do some of these different things. Moving on to enriching and vetting the attributes, we use Peyote, as I mentioned. That's the Python Open Threat Intelligence library. And it's an API framework that's built very modularly to kind of standardize all the disparate Intel APIs out there. Every API is different, the way you call them, what headers you need to send. And so when I joined the ISAC, this process, this was pre-MISP. This process was a process that took hours a day. I'd spent half my day doing this. We'd have to go through hundreds of indicators that are being shared, add them into a spreadsheet, and then take the spreadsheet and upload them to different. I did not like it, and it had to be a better way to do it. And so I started writing out some scripts, and as I was doing that, I'm like, hey, maybe this will be more valuable to others than just myself. So I decided to write it into a Python library. And the link's at the bottom. The top one is where you can find it. And I've also created a MISP taxonomy to go along with Peyote that we use as part of our enrichment tagging to the attributes themselves. These aren't all the services that are included in Peyote, but these are the ones that we use for our enrichment and vetting. So based on the different attribute types, determines on which services they're run through. Emails we're checking. SPF DMARC records, is this domain spoofable? Is it a disposable email address? Using emailrep.io to get reputation on the emails. Domains, getting domain risk scores, seeing if they're on reputation block lists. IPs, looking at the abuse confidence scores of them, also to see if they're on reputation block lists. Gray Noise Riot is a great service. Should note the ones that have asterisks here are kind of dual purpose. Therefore, also identifying potential false positives. Gray Noise Riot, for those of you that don't know, provides, it looks up an IP and it'll give it two different trust levels. There's two different trust levels that it can assign. So there'll be trust level 1, which means it's a cloud IP space that's owned and controlled by the cloud provider. So, like we don't want to pull in something and have it become vetted and it's really a Gmail IP and, a member blocks that IP and it takes out their entire email for a few days. And then it also provides trust level 2, which means, hey, this is a cloud, cloud IP, but it's not necessarily owned or controlled by the cloud provider. It's kind of rented out to them. Google Safe Browsing is great. If Google's already identified something as a threat, then, let's make sure we get that added. And then also Circle Hash Lookup, invaluable tool in identifying potential false positives. Sometimes we get members that share intel, and maybe they're sharing like the chain of events throughout several processes, and where like CMD spawned some VBS or whatever. We don't want to include that CMD hash in our vetted indicators and have a member block that. Again, that would be potential impact to their business. And then VirusTotal as well. They have their known software distributor. And so we kind of use that in conjunction with the Circle Hash Lookup to identify those potential false positives. But VirusTotal, we're also using that for hashes. If it's got a popular threat classification label, we're then taking that and then applying that as a tag to the intel itself. And so what this kind of looks like, Cobalt Strike beacon config uploaded to VT, config extracted. We've got one member that they pull down all these different Cobalt Strike samples, and then they're extracting the configs from Cobalt Strike, and then they're sending them over to us. And so we use that CS beacon config MISP object to then group these all together to keep that context there. And they'll share, it depends on how many, but there could be anywhere from 5 to 10 different MISP objects in one share. And so rather than sharing 5 to 10 different events, we use the object. They can group them all together and just share it at one time. And here you can kind of see some of these file hashes. These are the popular threat classification labels from VirusTotal, Trojan Beacon, Cobalt Strike, Java, etc. And here's some IPs associated with malicious SMTP authentication attempts. Once we've run our enrichment process in the vetting, we apply the tag to this enrich tag, so then that lets members know, hey, okay, this has already been enriched. We can pull this down. We take advantage of highlighting our taxonomy as well as the TLP taxonomy, because then right there at the top, it gets that breakdown. You can see the different, the source of where it was shared, the industry of the member who shared it, the threat type, etc. And then diving into this, we can see, as part of that peyote enrichment process, this first IP, Spamhaus, it's on their reputation blacklist, as well as Barracuda Central. This second IP's got a low abuse confidence score. It wasn't seen any reputation blacklists. But this third one is a high abuse confidence score. It's on 2 reputation blacklists. And so, again, this extra context helps our analysts, make better, well-informed decisions, kind of on the fly as they're doing their investigations. And then, based on our own criteria that we have in place, determines if an indicator or attribute will become vetted, and that just means that we're finding the known bad stuff, making sure there's no false positives in there, and then applying that tag, and then members will then consume the vetted indicators as a feed. It's not a feed in the MISP feed sense, but they'll do a search. Vetted ISAC vetted indicators for the last 24 hours, anything they pull, based on the indicator type. Maybe they're sending file hashes to their endpoint tools to do alerting or blocking on. Maybe they're sending other stuff to their SIM tools, or there's a lot of possibilities and a lot of ways in which they have that set up. And that kind of segues really good into this next slide, to the Intel interoperability and the integrations. Our team has currently helped integrations with over 17 named different platforms. These are all listed on the bottom here. We have several custom or one-off integration scripts, and quite a few more that we're currently working on. And so integrating as a member, what that process looks like. There's some that are one-click apps, maybe like the MISP 4.2 Splunk, where it's a Splunk TA app. You can just go in there, you can install the app, generate the key, configure it with the key and the tag that you're looking for and where the server is, and then tweak it as needed. And we also help integrate with custom scripts. And that process is pretty much the same thing. Just installing the app, generating the key, configuring it, and then making sure it runs on a cadence somewhere, cron job somewhere, or scheduled task. We also have a couple different integrations that we've developed and maintained for our members, mainly for Splunk, Microsoft Graph API, that can be used then in Azure Sentinel or Defender for Endpoint, CrowdStrike, and then just some generic scripts. So, we've got something that'll pull MISP for the last 24 hours, grab all the vetted indicators, in different languages like Python, PowerShell, curl, and our repo for those integrations can be found at the bottom. Sometimes we also have members that use an MDR or an MSSP. They want to integrate their tool with them, or their tool with our Intel. But since that tool is being managed by a third party, we kind of have a separate process laid out, which involves like having an initial discussion with our team, our Intel team, the member team, and that third party team. The vendor is the one that configures the integration on their end, and we just ask our member team to provide them the credentials, something that is credentialed under their domain, and then tweak it as needed and set up and get going. And we also have MISP synchronization set up. So, we operate our community MISP instance, and we have members that run their own, and they just set up the synchronization, and, they're pulling that intel down as we're publishing it. And when they want to share intel back to us, it's literally just a click of a button. That's part of their workflow. They're already working in MISP. And so it's great because they're not having to copy paste, go to Slack, send an email, log into another tool. It just helps kind of streamline that and make that intel more timely as they're sharing it. And what's next for the RH ISAC community? Next, we want to start looking at the MISP workflows. We operate by TLP Amber Strict, under TLP Amber Strict by default. So if a member doesn't tag something or share something with attributed TLP, we default to Amber Strict. And so that's like the first place I would like to go to where, using a MISP workflow to on publish, if no TLP tag, automatically apply the TLP Amber Strict tag. I know there's a ton more things we could do there, but we haven't leveraged the workflows at all. And so that's kind of where I'd like to start. And then the warning lists too. I have a couple of them enabled currently, but I think that's a more valuable resource that we're not leveraging enough. And that's also there to help identify more potential false positives, whether using existing ones or being able to create our own. We've had a few times where, as part of that enrichment and vetting process that's automated, had a member reach out and say, "Hey, I think this one might not be, 100% malicious. I think it's more just an indication of activity. Certain stuff like to CDN sites." That's the main example that jumps to my head. So, looking to leverage the warning list more, because then as a member, they can, as part of their integration, we'll still do the vetting the same, but then they can say, give me the last 24 hours of the vetted indicators, but I want you to enforce warning lists, and then this will prevent them from pulling any indicators down that have been flagged as being on any of these warning lists. And then lastly, we'd like to do more contributions to the MISP community. And I think our first place we're going to look to do that is going to be through the MISP fraud galaxy that we're working on. There's nothing proprietary in there, and I think it'd just be good for the whole sector rather than kind of keeping it within us. And so that's kind of what we're looking for. Next steps. And before I take any questions, I just want to say a huge thank you to Circle, one for hosting this, having me come, and two for all the fantastic work that you guys do, including working on MISP. And with that, I'll pause and open up to any questions.
Questions? So I'm going to be the annoying guy, considering you're sharing IP addresses. What is your GDPR policy?
I'm from America, and so we don't.
But the IP addresses might be European. It still affects you.
True. But in all seriousness, I guess that's not something that we've really considered too deeply, as we don't have to follow GDPR as we operate out of the United States. However, that's not to say that we have plenty of international members from Europe as well, and so I'm not sure where to go, because that's not something I've had to really think about.
I can answer these questions. On the MIST project page, you have a directory/compliance for GDPR, and you have plenty of documents about GDPR and compliance of information sharing. And